Hi friends, here we have one more content. Explain Kirchoff's laws with examples. Okay, this is one of the important content. Okay, before actually Kirchoff's laws, we have Ohm's law. Okay, why we won't use Ohm's law? Ohm's law is applicable for only few circuits, but Kirchoff's law is not applicable some circuits, so that Ohm's law is not used for complicated circuits. Here we are going to use Kirchoff's laws. Okay, due to that reason they introduced one of the concept, Kirchoff's laws. Okay, here two laws of Kirchoff's are there. One is junction rule and second one is loop rule. Okay, here we have two rules are there given by Kirchoff. Okay, one is junction and second one is loop rule. First let us discuss junction rule, later we will discuss loop rule. Okay, what is meant by junction? Junction is nothing but it is the combination of all roads, okay, at one point, like circle. It is forming like circle. That point we are calling it as junction. Okay, but in this electric current, junction is nothing but all the flow of currents are combined at one common point. All the flow of currents are combined at one common point. Nothing but all wires are combined at one common point. Okay, according to junction rule, the amount of current coming toward the junction point is equals to the amount of current leaving is remains same. This is the rule which is given by Kirchoff's, that we are calling it as junction rule. Okay, here I will draw one diagram, then you can understand very easily. Here is the junction point I am considering. Different directions I am taking, like this. Okay, let us suppose some of the wires which are carrying current towards the point. Okay, let us suppose I am considering this and this, which are carrying current towards the junction point. Let it be, I am taking it as I1, this is I2, this is I3, I4, I5 and I6. Totally 6 wires are there. Okay, I1, I3, I5 are the currents which are coming toward the junction, whereas I2 current is leaving away, I6 current is leaving away, and I4 current also leaving away. Okay, according to junction rule, the sum of the current which is coming toward the junction is equals to the sum of the current leaving away from the junction. With this example you can conclude. Okay, here I1 is coming, sum of the currents I1 plus I3 plus I5. These are the amounts of currents which are coming. Total amount is equals to the amount of current which is leaving away. I2 is leaving away plus I4 and I6. Okay, the sum of the current which is coming toward the junction is equals to the sum of the current which is leaving away from the junction. Okay, this is called junction rule. Okay, in this we will take one point. What is that means? So this is based on law of conservation of charge. Okay, here the junction rule which is takes place on basis of law of conservation of charge. Okay, charge neither can be created nor can be destroyed. It will flow from one place to another place. Okay, so the sum of the current is coming toward the junction is equals to the sum of the currents which is leaving away from the junction is constant. This is junction rule. We can define this junction rule in another way. What is that? The algebraic sum of current at a junction must be equals to 0. Algebraic sum of current must be at a junction is equals to 0. Okay, here all the currents which are coming toward the junction, if you will consider it as positive, and the leaving you need to consider it as negative. Otherwise, all the current which are coming toward the junction is negative, and leaving away must be you need to consider it as positive. Okay, but algebraic sum must be equals to 0. On basis of this, what you will get? Here coming toward the junction, I am considering it as plus and leaving away minus. So I1 minus I2 plus I3 minus I4 plus I5 minus I6 is equals to 0. Okay, I1, I3, I5 coming toward the junction we considered positive. I2, I4, I6 which are leaving away, so we need to consider it as negative. So we will get one more statement. The algebraic sum of current at a junction must be equals to 0. This is junction rule. Coming to loop rule. Here in this loop rule, which is considered on basis of energy. This is on conservation, law of conservation of energy. Loop rule is considered on basis of law of conservation of energy. According to this, what we can say? Loop rule. Okay. According to loop rule, the increment, the potential difference either increasing or decreasing. The potential difference either increasing or decreasing at different devices or across the different devices in a closed loop must be equals to 0, or else the algebraic sum of the product of current and resistance across all the devices must be equals to 0. You can take any one of the statements. According to loop rule, two statements. One is either increasing or decreasing potential difference across all the devices which are connected in the closed loop must be equals to 0, or second statement, the algebraic sum of product of current and resistance in a closed loop must be equals to 0. These are the two statements we have. Okay, here we are considering with one example. Here I am taking one circuit. Here is the circuit I am considering. This is the resistance R1, R2. This is R3. Here is the EMF, which is represented as E, E1. Here this is E2. Here I am naming it as A, B, C, D, E and F. Okay, right now if we consider this is the EMF E1, then electric current starts flowing. Here the current coming from here is I1, and here the current coming here it is I2. The sum of the current This is the junction point, so that some of the currents which are going through this I1 plus I2, and again how much amount will be back? The same amount will be back, so we'll get I2. Here this is I1. The amount of current coming from the positive terminal is equal to the amount will come back is remain same. So negative terminal will be I1 itself. Okay. Right now, according to loop rule, the algebraic sum of product of potential, product of resistance and current remains constant, or else the increase in or decrease in potential energy, potential difference in a closed loop must be equals to 0. Okay, you can take any one of the statement, but actually I want to tell you one small point for easy understanding. What is the potential difference between these two, and what is the potential difference between these two? Here the potential difference, I am considering it as V1 for easy understanding. V1 is equals to E1 minus I1 R1. Here we have a statement, potential difference. Here this is the energy, total energy, and this is electric bulb or any device which is utilizing. So what is the potential difference here? V1 is equals to total energy minus utilized. So V1 equals to E1 minus I1 R1. Similarly in this V2 is equals to E2 minus I2 R2. What is the potential here? There is no source, so we will get potential is I1 plus I2 into R3. The algebraic sum in a closed loop must be equals to 0. Here what is the direction if you consider in this forward? Here this is backward. So you can take equal in parallel combination of resistances, like, okay, in parallel combination of resistances, potential difference will be equal condition. You can take the condition and you can solve for that. Okay, right now according to that, if you come the circuit, first circuit I am taking, what is that? A, B, E, F, A. Potential difference in a closed loop must be equals to 0. So we can take V1 is equals to V2, or else V1 minus V2 equals to 0. Why we are taking minus opposite in direction? So we'll get that. So directly I am writing E1 minus I1 R1 is equals to E2 minus I2 R2. Bring those to left side or send these to right side. You can take any. So final equation we can write E1 minus E2 minus I1 R1 plus I2 R2 is equals to 0. This is number 1, first equation. And you can take one more circuit. Circuit 2. A, C, D, F, A. A, C, D, F, A circuit. A, C, D, F, A. What is the potential difference? Here is the potential difference. What is the potential here? This is the potential. So we can make them equal, or else V1 minus this equals to 0. Okay, you can take any one of the conditions. So directly I am writing E1 minus I1 R1 is equals to I1 plus I2 into R3. So you can bring that and you can write left side. So E1 minus I1 R1 minus of I1 plus I2 into R3 equals to 0. This is the second equation. Here this is first. Here this is second. and directly I'll write a third one. Similar process, B, C, D, E, B. B, C, D, E, B circuit, so that what you will get, E2 minus I2 R2 minus of this equals to 0. So directly I am writing E2 minus I2 R2 minus of I1 plus I2 into R3 equals to 0. This is third equation. Okay, this is about loop rule. Okay, here Kirchoff's laws giving you two laws. First one is junction rule, second one is loop rule. Loop rule is on basis of law of conservation of energy. Junction rule is on basis of law of conservation of charge.